how we farm is changing. The use of UAVs for observing, measuring, and responding to crop and field conditions is the latest in technology, and it's only scratching the surface.
Precision agriculture, it's a large industry, so it's taking things like the precise placement of seeds, the precise treatment of herbicides and pesticides, irrigation and water management, and it's putting all of that together in a way that increases the crop yield while it's decreasing the input costs. Unmanned aerial systems supports precision agriculture because it provides data that can be processed into information to help you make better decisions in a more timely fashion.
When we fly over a field with a UAV, we're collecting several types of data. Most clearly are RGB types of images, which was just like what you would see on Google Earth or Bing imagery. At the same time, they're also collecting an infrared image, which is heat sensitive, so you're looking at the hot areas of the field, the cool areas of the field. And when they collect those types of data, they can put them together and give us a vegetative index map, which will show areas of good, healthy growing crops, poor growing crops, whether they're tall or short or greener than others. The hot spots in a field could indicate several things. Soil type being warmer, which is a good thing early in the season. We could be looking at stress factors. Maybe there's less water available to that crop. That crop is heating, which would be a bad thing, essentially detrimental to our yield at the end of the year. Several factors, possibly disease if we have disease moving in. The thermal images or heat, looking at heat, could tell us where the disease would be at in the field.
We're trying to understand more about how what we do in the field translates to yield. And the part that is exciting about the UAV is if we can figure out by looking at the crop as it's growing and recognizing certain issues, can we make a decision to correct those issues and correct them soon enough to make a difference in yield. I see the potential that if we can learn enough about how the pictures actually pick up problems in the crop, I think it can be very helpful. If you have an aerial picture, you can at least go prudently scout where you see a problem, figure out what the problem is, and then hopefully be able to say, okay, this is the problem we see in this corner. The opposite corner looks the same coloration. Let's go see if it's the same problem, because it's just very hard to look over lots of acres efficiently when the crop gets bigger than about waist high. The pictures we took today, which would be after harvest pictures, can I see the soil type differences? This year in many fields, there was excess of water in the black ground, and the clay ground yielded better. But the maps that we go off from the government that show soil type were made many years ago with less advanced technology. So what I'm trying to do today with taking a fall picture, can I see the soil type differences in this post-harvest picture enough to draw a better map for next spring's decisions?
Collecting the data from the UAV imagery is going to be important moving forward. We'd like to build a database. That database we'll be able to use to make those important decisions. We need to build up probably 3 years of a rotation so that we can start to see historical patterns, cropping patterns, and then move forward with that imagery and make those types of decisions.
The National UAS Training and Certification Center at Sinclair Community College in Dayton is training UAS operators, the pilots, the observers, maintenance, and data analysts.
Sinclair really looks at unmanned aerial systems as being one of the next big things. It's going to be a huge employer for the country nationally, but certainly for the state of Ohio. It has a lot of benefits for existing industries. And so we really view ourselves as an enabler. And so we're connecting students with potential employers. We're enabling industry to develop and operationalize technologies that can help them. And then forming those collaborations and partnerships that hopefully we can help broker.
Most farmers do not have the time or want to invest in UAV systems. 3D Aerial Solutions is a Dayton-based company that provides aerial imagery and data processing. They were one of the first commercial UAS businesses in the country to be granted a Section 333 exemption by the FAA. This allows them to fly UAVs legally over farm fields.
So we're required to have a visual observer to make sure that we stay out of the way of manned aircraft. There's a geofence that shows up around the work area, and if a wind were to blow the aircraft into the geofence, then the aircraft autopilot will take over and it'll return to the land area. So that we won't have any flyaway conditions with this aircraft. Ready to launch.
I think we've got the technology to do a lot of exciting stuff. We're collecting a lot of data from UAVs, we're collecting a lot of data from the harvesting equipment. We can apply things relatively precisely with the planters and sprayers. I think the technology will allow us to do a lot of cool things. We still have to have the human element to make those judgment calls. It's quite a challenge just pulling all the pieces together. So what we're trying to learn from the picture data is variations in the crop that may need attention, and once we understand that linkage, then we can go into the tractor and program the tractor to apply different rates of herbicide or seed or fertilizer. But at the moment, what we're doing is really doing a study ahead to make wiser decisions.
There's an economic impact analysis that there's going to be 100,000 new jobs in the economy over the next 10 years. Thousands of those will be in Ohio, and 80% of all small UAS operations will be in support of agriculture. So being that agriculture is Ohio's largest industry, it's a natural fit.
As a farmer, I see a lot of potential with the future of UAV imagery. We're going to be able to fine-tune our operations in crop and in season like we never have before. Moving forward, I think we're only going to be more specific about chemistries and herbicides and fertilizer, and we're going to use less amounts of that across the fields, and UAV imagery is going to play an important role of that process.